Hello, I hope everyone is doing well. Today we will be starting our lesson on ellipses, and tomorrow we will finish it. So it will be a two-part lesson here. The assignment, the worksheet that I'll give you today, again, it'll be the entire worksheet, but you'll have part of it to do today, part of it to do tomorrow, and then looking to give you guys a quizzes starting on Friday, and then you'll have till Sunday evening to submit that. So our goal for today is to be able to write the equation of an ellipse from general form to HK form, and also to be able to graph. So to look at the two versions again, which we already looked at when we first started identifying conics. We'll revisit those again in more detail. We have two directions an ellipse can sort of face, if you will, or just sort of be drawn. We have horizontally, which means the length of the ellipse, and we're going to refer to these as minor and major axes instead of a radius. So I'm looking at this first ellipse in blue here where it is longer horizontally. So again, with a circle we can call it a diameter, but here with an ellipse we can't. When it's longer horizontally, this is called the major axis. And then we have the shorter one that we're going to draw vertically here. And the shorter one is called the minor axis. Going over here to the red ellipse, the major axis is now vertical. There's our longer one. And our minor axis is shorter, going horizontally. All right, so now I'm going to refer to when the major axis is horizontal or the major axis is vertical to help us understand the direction. Again, we can't look at an ellipse just like a circle with having a radius, constant radius throughout the entire picture. So our equation in HK form is going to be x minus h, the quantity squared, over a squared, plus the quantity y minus k squared over b squared equals 1. When our major axis is vertical, the numerators stay the same, so we're still going to have x minus h squared, but this time it's going to be over b squared, and there's always plus in the middle, y minus k squared over a squared equals 1. So a squared and b squared are going to be numbers, and how are we going to tell where each one is? A squared is always the larger number. I'll say the larger value. So that's how we could tell when we're looking at an equation or when we go to put an equation in this HK form, everything we're going to need in order to graph it. The center is the same for both of these. It's always HK, just like the center that we get from a circle. And then we're also going to be asked to find the length of the major axis. So this a squared, I'm going over to the blue ellipse here. We're looking at a squared, so just like a radius, a is going to be from the center over to, we'll call this a vertex, or each vertice that's right here. So if it's a units long from the center over to the edge of the ellipse, and then another a over here, that means the length of the major axis is going to be 2 times whatever the a value is. And the length of the minor axis going along the minor axis, again going back to the blue ellipse here, from the center up, the shorter part, again it acts just like a radius, but it's a different length. This is going to be b, and then down from the center to the edge of the ellipse over here is going to be b. So the minor axis length will be twice whatever the value of b is. And then we also have vertices at the ends here and here. So I'm going to put all these yellow marks here. They're going to represent vertices. Okay, so the vertices are the endpoints of each axis. So when we go through our examples, I'm going to point those out as well. So we have 3 examples we're going to go through. All right, so for our first example, this is the form. If you notice, this is already in HK form. All of our examples today are going to be, for the most part, in this HK form. Tomorrow's lesson, we will be completing the square to go from that general or standard form to HK form. So the first thing we need to be able to figure out is the direction of the ellipse. So if you notice, my 2 denominators, 25 is larger, so this is a squared. So a squared is 25, and because it's in our first fraction, or it's under the x squared, our ellipse is going to be longer horizontally. So we'll have a sideways ellipse. So if a squared is equal to 25, a is equal to 5. The 4 here is b squared then. So if b squared is equal to 4, then b is equal to 2. My center, I go to the numerators. Notice there's nothing up here in parentheses, so just like a circle, if we just had x squared plus y squared, that means h and k are both 0. So I'm going to go ahead and plot my center at the origin. And since we know it is longer horizontally, this a is equal to 5 means I'm going to count over 5 to the right, make a point here, 5 to the left. Whereas a circle having a radius of 5 means I count 5 right, 5 left, 5 up, and 5 down, but what I'm counting up and down is not also 5, it's 2. So I'm going to count 2 up and then 2 down. So my center was at 0, 0. My a was 5, so because that 25 was the first denominator, my ellipse is longer horizontally. And again, as best you can draw this. So this is what we are looking at now. I'm going to just change the color so it's easier to see. All right, so what we also want to do, I'm going to write in the vertices here. So we have 4 vertices. We have this at -5, 0. We have another vertex along the length of the major axis here would be at 5, 0. At the top of the minor axis, this would be at 0, 2. And we have another vertex here at 0, -2. Just to write off to the side, the length of the major axis, if it's 5 to the right from the center, 5 to the left, it's going to be 2 times a, which is 2 times 5. So the entire length of my major axis is 10 units from vertex to vertex. The length of my minor axis is from center to the top here is 2, center to the bottom here is 2, so it's 2 times 2, so I have an entire length of 4. So we'll write in 4 units for each of those. 10 units and 4 units rather. All right, so in the most basic form, determining the direction, the center, the lengths of the major and minor axis, and being able to graph our ellipse. For example, 1 is done here. All right, example 2. We have x minus 2 squared, that's over 16, plus y plus 3 squared is over 64. And again, that's going to equal 1. All right, it doesn't matter what we determine first. If you wish to identify the center, going back up here to x minus 2, so h is 2, k is going to be a -3. So I have a center at 2, -3. I'm going to go ahead and plot that on my coordinate plane here. Looking at the denominator, 64 is larger, so this is where I write a squared is equal to 64, which means a is equal to 8. That makes b squared equal to 16, and b is going to equal 4. So because 64 was in the second denominator, a squared is in the second denominator, this means I have an ellipse that is longer vertically. So I have sort of an up and down ellipse rather than it being horizontal. All right, so what I'm going to do now is from my center, I'm going to count up 8 and then down 8. And it does take me off my graph a little bit, but that's okay. For the minor axis, I'm going to count 4 to the right and 4 to the left. All right, and then this is what, move that over. This is what I'm going to draw my ellipse through. Let me try redrawing that again. There we go, much better. All right, so drawing in our major axis, again, this should be 8 and another 8. So we have a vertex up here, looks like at 2, 5. And we have another one here at 2 and negative 11. So our major axis, which should be 2 times a, so 2 times 8, which is going to give us 16 units. Our minor axis, going from the center over, that has a length of 4 and another 4, so 2 times 4 will give us a length of 8 units. All right, we also have vertices here. This looks to be 6, negative 3, and then negative 2, negative 3. All right, so writing in each vertex here, we have our major and minor axes drawn in and our ellipses graphed. All right, so let's take a look at our third example. We'll start with x squared plus 9y squared equals 9. So it looks a little different from our first two examples. We don't see two fractions. We definitely don't see it equal to 1. So the trick here, now notice there's only an x squared and a y squared. We don't have just a linear x term or a linear y term. So there's nothing to worry about like completing a square. All I want to do now is just turn this 9 over here at the end into a 1. So I'm going to end up dividing by 9. Everything up here gets divided by 9. So this will now give me x squared over 9 plus y squared. Let's keep it as a fraction, so over 1 equals 1. So now this is in that HK form. My center, like example 1, is 0, 0. So I'm going to go ahead and plot that. 9 is a larger number, so 9 is my a squared, and then a would equal 3. 1 is my b squared. Square root of 1 is 1. So this ellipse is going to be longer horizontally. So I'll have an ellipse that looks like that. So from my center, I'm going to count 3 to the right, 3 to the left, but I'm going to count only 1 up, 1 down. So here is the ellipse I'm going to draw. Looks like that. Go ahead and write in the vertices. So one vertex at the end here is going to be 3, 0. The other one at negative 3, 0. I have 0, 1, and 0, negative 1. Length of the major axis is going to be 2 times A, so 2 times 3, so I have 6 units. We'll go back to the picture and count as well. And then the minor axis is going to be 2 times B, so 2 times 1 is just going to be 2 units. Remember, you can also check on your graphing calculator or Desmos. Go ahead and type in the equation for each one and then see what graph it's giving you. So just an introductory lesson on the HK form, understanding now what will cause the different direction of the ellipses, what a squared and b squared are, and how to determine those when they're in our denominators lead us to the direction here. So your homework assignment, I'm going to post this as a separate PDF, but it's also at the end of this video too. So on the worksheet so far, there's 2 sides to it. You're doing one, just parts A through E, and number 2 is actually connected to number 1. So I want to show you real quick what this is. So you're not doing part F. So for 1A through E, it says for each of the following, determine the center of the ellipse and the endpoints of each axis, which is just the vertices. Again, you'll have 4 vertices for every ellipse, the 2 at the end of the major axis and 2 at the end of the minor axis. So notice all of these, for the most part, are in that HK form. There might be one on there, like our third example, so you don't have to do too much for it. So you're identifying the center, the endpoints of each axis. Also write out the lengths of the major and minor axes. And I'll include this in the directions on the PDF as well. Number 2, again, goes back up to A through E. Sketch the graph of each of the ellipses in question 1, and then check your graph on your graphing calculator. So you could put 2, I wouldn't recommend any more than that, 2 ellipses per coordinate plane. If you don't have graph paper, that's fine, but please draw your coordinate planes very neatly with a ruler, and then make sure you also number the units, talking about how to evenly space them when you go to graph those, so you get the most accurate graph as possible. Just to show you the rest of this, the lesson for tomorrow, we will be able to look at the equations or the graphs of ellipses already and then write the equations. So number 3 has 3 parts, and then the last page, 4, this is where we're going to get into completing the square to go from this general form to HK form, and then again be able to graph the ellipses as well. So I will put this worksheet as a separate PDF. This will be the assignment for tomorrow, and then on Friday I will assign a quizzes over ellipses. Should be around 17 problems. You'll have a couple days to complete that. So as always, please email me if you have any questions, and take care, guys.